All right. Hi, class. Very good evening, everyone. Very good evening, everyone. All right.
Hi, class. Very good evening, everyone. Very good evening, everyone.
Okay. All right. Yes, guys. Quickly update all your friends that the session is live. Good evening, Ricky. Very good evening, all. Good evening, Minmoy. Good evening, Dileshwar Rao. Very good evening, all. All right, come on, let everybody join quickly because this is an important session. The previous session I took on linear algebra from mathematics, where we discussed all branches 5 years previous year questions, and today we are going to take up the previous year questions 2021 to 25, 5 years. All branches. And a very crucial topic, random variables. A very crucial topics of random variables. Good evening, Samukha. All right, guys, so quickly, yes, update all your friends about the session. Let's get started. Important one. Let's see the variety of questions in the past 5 years so that you understand the trend as well. Good evening, Ganesh. Okay, so let's get started. Let's get moving on. Okay. Yes, very soon you will get the updates about mega marathons as well. Okay. They are going to happen, don't worry, on the Om Institute channel, and you're going to get update about that very soon. Okay. So guys, let's get started. And yeah, before I start, a very important update that those who are willing to prepare for GATE 2027 or 28 and looking for some financial assistance, the Om Institute brings to you the online scholarship test for the GATE 27 and GATE 28 online courses. Yes, guys, this examination is going to be conducted on 25th of January. Okay, from 6 p.m. to 6:50 p.m. That is a 50 minutes examination. All right. Okay, the syllabus for EC and respectively basic fundamental subjects are mentioned here. The syllabus has been mentioned, and okay, based on your performance, what discount you get. Like if you get the rank in top 3, you secure 100% scholarship, and based on your rank, you get the amount of scholarship which is clearly mentioned here. Okay, so the mode of the test, as I told you, will be online, conducted on the Om Live app. Okay, or if you want to go for web, ominstitute.live. Okay, 50 minutes exam containing total 20 questions. Any queries, you can contact our support numbers. Okay, so yes, guys, if you want to register, you can immediately register also by scanning this particular QR code. Okay. Yes, Ricky, definitely. Now, this particular session is important one from mathematics point of view, or if you are an EC student, it is also very helpful for your communications as well. Okay, totally relatable. Okay, so first question here, guys. Okay, first question here. So as I did in linear algebra with questions, okay, if required, whatever the basic review of the theory is required, that we will keep doing. Okay, don't worry about that. Okay, whatever formulas or basics are required, we'll definitely review and then keep solving the question. Okay. All right. So guys, here it is. X is a discrete random variable which takes the value 0, 1 and 2. The probabilities are given, okay, 0.25 and 0.5 for x equal to 0 and x equal to 1, where E dot denoting the expectation operator. What is the value of Ex minus E of x square? Okay, so guys, here it's a simple 1 mark question. I'll tell you why. Let's have a see, because whenever you have a discrete random variable, you define the PMF, okay, which talks about the probability of any value of random variable. P of x, probability of x, it is simply meaning that what is the probability that the random variable x, here I have named a random variable as capital X and the value is named as small x here. P of x means what is the probability that x takes the value small x. Okay, remember, since it is a probability calculation, it is always between 0 to 1, and summation of PMF, okay, summation of all probabilities is equal to 1. Okay, this particular function, okay, for a discrete random variable, is known as the PMF function. Okay, is the PMF function. Now, the question is on expectation, although this small point will also be used, sum of all probabilities, summation of PMF equal to 1. Why? Because they have only given you two probabilities. Okay, what are the values taken by x? The values taken by x are 0, 1 and 2. Okay, what are the probabilities? Okay, the probabilities P of x. Okay, so for x equal to 0, probability 0.25. For x equal to 1, probability 0.5. That is the only data. What is the probability here? Okay, what is the probability here? So sum of all probability has to be 1. So what should be coming up here? 0.25. Then only sum of all probability will be 1. Okay, so number 1, we complete all the probabilities. Okay, good evening, Bhanu. Okay, then expectation. Okay, quick revision of the expectation formula. Okay, so here it is. What is the expected value or mean of x? Expected value is given by summation of x into PMF. Similarly, when we revise the formula for continuous random variable, the similar formula converts to integral x into PDF. Okay, there we'll talk about the PDF function. The nth moment is defined as the expectation of x power n given by the formula summation of x power n into PMF. Okay, then variance is defined by the formula expectation of x minus ex whole square, expectation of x minus mean whole square, and of course, this is the official formula, but for variance, normally we will use the identity always. How do you calculate the variance? E of x square minus ex whole square, E of x square. Okay, second moment, also known as mean square value, like nth moment is E of x power n. Okay, E of x square, okay, which becomes the second moment, or also known as the mean square value of the signal. E of x square, because expectation is what? The mean operator. Okay, the mean of square of the value, the mean of square of the variable, mean square value, and that is given by summation x square into PMF. Okay, every value square multiplied by respective probability. Okay, so variance will always be calculated by E of x square minus ex whole square. Okay, standard deviation is root over of variance. Now, the linear function, if y is ax plus b, one common question that you get from here, okay, is on the linear function y equal to ax plus b, expectation of y is a ex plus b. Okay, variance of y is simply a square variance of x. Okay, now if it is continuous random variable, remember that continuous random variable can take all values in a given range, so the total number of values it can take are uncountable and infinite. That is why probability it takes any value is 0. Okay, probability, the simple logic you can apply is like 1 by infinite. What is the probability of any value? Okay, favorable by total. How much is the favorable value? I am talking about any one value, x equal to a. Total values, because it is a continuous random variable, if it is defined, suppose this is the x-axis, if it is defined between 2 points x1 and x2, it can take any real value between x1 and x2, and if you count all real values between x1 and x2, these are uncountable infinite values. Okay, that is why the probability of certain range is calculated by probability a to b. Okay, probability that x lies between a to b is integral a to b fx dx. Okay, how this PDF function comes up, as I told you in linear algebra session also, we will not focus on derivation, but quick review of the formula and how do you apply to the question, how is the technique to solve the question. Since it's like a revision session, so I'll not go for any derivation. Okay, this fx is known as the PDF function, and since, okay, it's a PDF probability density function, again it must be positive and integral of PDF. Okay, like summation of PMF1, here integral PDF, integral minus infinite to infinite fx dx, which can also be written as probability from minus infinite to infinite, which is of course 1. Because any random variable you imagine in the world, okay, what is the probability it takes the value from minus infinite to infinite? It is always going to be 1. Okay, because there is nothing outside the range minus infinite to infinite. Okay, now again expectation, as I told you, similar formula, just that summation will be replaced by integral. Okay, expectation of x, integral x into PDF. Okay, integral x into fx dx. Expectation of x power n, integral x power n fx dx. Okay, variance, again use the same identity for variance, E of x square minus ex whole square rather than the official formula. Okay, mean square value minus square of the mean. Right, if y is ax plus b, same formula I am telling you here, mean of y is a mean of x, this is a e of x actually, plus b. Okay, variance of y, a square variance of x. Okay, if y is any function of x, then expectation of y. Okay, expectation of y, or this is like expectation of g of x. Okay, as I've already told you, whatever expectation you need to calculate, that should be inside the summation or integral. Okay, so integral gx into fx dx. Okay, fx means the PDF again. Okay, if the PDF of a random variable is even symmetric, then its mean will be 0. Why? Because you simply see the logic here only, na? Okay, what is the mean? Integral x into fx. Okay, x means x power 1, odd function, and fx, if fx is even, odd into even will be odd, and integral minus a to a for any odd function is always 0. Integral minus a to a for any odd function is 0. Okay, so if the PDF of a random variable is an even symmetric function, then the mean is anyways going to be 0. Okay, then sometimes you may get basic questions or identity-based questions around covariance and correlation. We'll see that also. Okay, covariance between two variables, covariance x comma y is defined as expectation of x minus mean of x, y minus mean of y, and it is also equivalent to expectation of xy minus e of x into e of y. Okay, now first let me come to this point. If x and y are independent, okay, then expectation of xy is given by e of x into e of y. So if these two are equal, what will happen? Covariance will be 0. So if two random variables are independent, their covariance will be 0. They will be uncorrelated. If two random variables are independent, they will be uncorrelated. Okay, covariance of sum of random variable, variance of sum of random variable, variance x1 plus x2 is given by variance x1 plus variance x2 plus twice the covariance x1 comma x2. But if the random variables are independent, I told you covariance part will be 0, then the variance is additive. Variance of x1 plus x2 or variance of x1 plus or minus x2. Both I will include here. Variance x1 plus minus x2 is given by variance x1 plus variance x2. Remember, variance is never negative. Okay, it's always going to be additive in nature. Okay, I'll write down one more point here about the variance wherever we discussed. See, remember, variance of x is always greater than equal to 0. It is always said to be non-negative. It may be worst case 0 if the data is constant, otherwise positive. Okay, the variance is non-negative. But if you talk about covariance, okay, if you talk about the covariance, covariance could be positive, negative or 0. Okay, Cauchy-Schwarz inequality for covariance. Okay, covariance x comma y whole square is always less than equal to variance x into variance y. Last thing, correlation coefficient, if they ask you by chance, what is the correlation coefficient, rho? Okay, the correlation coefficient between two variables is given by covariance xy divided by under root variance x into variance y. Okay, covariance xy divided by root over variance x variance y, right? Okay, all right. So yeah, let's go back to the question and complete the question. What is there? So the random variable takes the value 0, 1, 2 with the probabilities. Two probabilities were given. One I have written here. Okay, question is e of x minus e of x square. Now look into the calculation part. What is the value of ex? What is the value of ex? Summation of x into PMF, correct? Okay, every value multiplied by respective probability, summation x into PMF, right? Now, if you multiply the respective terms, 0 into 0.25, 1 into 0.5, 2 into 0.25, right? I'll write down this way, 0 into 0.25, then 1, every value into respective probability into 0.5, okay, plus 2 into 0.25. So this looks like how much? 0.5 plus 0.5. This will be 1. Okay, and then when I am required to calculate e of x square, what will be e of x square? Summation, second moment, mean square value formula, summation of x square into PMF. What is this value equal to? Summation of x square into PMF. What is this value equal to? Every value square. Like here I have written 0. It will be 0 square into 0.25. 1 square into 0.5. 2 square into 0.25. This looks like how much? 4 into 0.25, 1. This is 1.5. Okay. So what is the question? The question is, okay, ex minus e of x square. This becomes 1 minus 1.5 minus 0.5. Okay. Minus 0.5 is the answer. Okay. Next question. Yes, correct, Samuka. Minus 0.5 is the answer. X is a random variable that can take any one of the values. Gate 25 civil 1 mark, as I told, all branch questions I have included for a good practice. Okay, that can take the value 0, 1, 7, 11 and 12, and the probability mass function for x is given to you. Okay, that means every value and its probability is respectively mentioned. I'll write down the probabilities here. For 0, how much they have mentioned? 0.4. For 1, what is the probability mentioned? 0.3. For 7, what is the probability mentioned? 0.1. For 11, what is the probability mentioned? 0.1. For 12, what is the probability mentioned? 0.1. Correct? Okay. So, still sum of all probability will be 1. You can tally it. Okay. What is the variance? So, as I told you, variance will be calculated only by the identity e of x minus e of x whole square. Okay. So, let me start with the calculations here. Okay. What is the e of x? as I told you, summation of x into PMF. Every value multiplied by respective probability. 0 into 0.4, 1 into 0.3, 7 into 0.1, 11 into 0.1, 12 into 0.1. Okay, this is the calculation required for the mean. Okay, what is going to be mean? So this becomes 0.3 plus 0.7 plus 1.1 plus 1.2. Okay, so net is how much? 2.33. This is 3.3. If they ask the mean, answer is 3.3. Okay, but for variance, one more calculation I need, and that calculation is E of x square, meaning summation of x square into PMF. Okay, x square. Okay, so 0 square will be 0 only. 1 square will be 1 only, 1 into 0.3. 7 square will be required, so which is 49. 49 into 0.1. 11 square, 121 into 0.1. Last calculation, 12 square, 144 into 0.1. So how much is this calculation? This part is 0. This is 0.3 then, plus 4.9, plus 12.1, and plus 14.4. How much it should be turning out to be? 12 and 14, 26, 30. Okay, and 31, 31.7. Let me recheck it. 26, 30, correct? This is 31 and 0.7, 31.7. Okay, now what is the final answer for the variance? Only little calculative. Okay, only this question is little calculative. What is going to be variance of x? Okay, E of x square, mean square value minus square of the mean, minus E of x whole square. What is the E of x square calculated? 31.7 minus EX, that was 3.3. Okay, 3.3 whole square. Okay, this is how it is going to be calculated. So you can calculate the approx answer and let me know, and just hold on for a second here. Okay, yeah, let's continue here. Okay, yeah, of course. So approximately 31.7, the closest answer. 20.81, yeah, you can just mark it directly. 20.81 is the closest answer that is going to be matched. Correct answer, Samuka. Correct answer, Bhanu. Okay, so again a question, little just calculative but direct question on the formula of variance. Next question it is, the probability density function, continuous random variable based question, okay, is given as a e power minus 2 mod x. What is the value of a? Gate 22 electrical 2 marks question it is. Okay, so directly PDF of a random variable is given, and okay, how are you going to solve this? To find the value of a or to find the value of any unknown given here, just solve integral minus infinite to infinite fx dx should be 1. Okay, that means integral minus infinite to the infinite fx, that is a e raised to the power minus 2 mod x dx. This must be equal to 1. But now you see that modulus of x is an even symmetric function. Okay, now modulus of minus x is what? Modulus of x. Okay. So what can I do? Integral minus a to a can be written as twice integral 0 to a. Okay, twice integral 0 to a e power minus 2 mod x dx. This should be 1. Now listen to me carefully. A is outside, but now I have made the integral limit as 0 to infinite. Now if the integral limit is 0 to infinite, means positive limit. Okay, what is the value of mod x? For positive limit, mod x will be simply x, na? Okay, modulus of positive number, modulus of 5 is 5, modulus of 100 is 100, modulus of x will be x only. Okay, so simple integration is left, e power minus 2x dx integral, and you have to equate it equal to 1, right? So 2a e power minus 2x divided by minus 2, limit 0 to infinity. This is 1, 2 is got cancelled, minus of a, upper limit e power minus infinity 0, lower limit is 1. E power 0, 1. So minus a into minus 1. So a only. A equal to 1. Check your answer, please. A equal to 1 is what is you are getting. Correct, Bhanu. A equal to 1 is the right answer. Okay. Okay. Yes, Sabita correct answer. Samukha correct answer. 1. Next question, dear. Have a look into it. Gate 25 CS 2 marks question. Come on, give me the answer for this one, everybody. Okay, guys. Yeah. Let us check the answer for this one. Gate 25 CS 2 marks question. The probability distribution given by the density function Px. Okay, Cx square when x is between 1 to 1 and 0 otherwise. What is the probability that x lies between 2 to 3? See, if you are required to calculate this probability and it's a NAT question, okay, only numerical answer is required. That means what about the C? It is not given. Some constant C is given. So first you have to find C. Okay. Bhanu has some answer already, and then the probability will be calculated. Okay, so first of all, what is the C value? Okay, again, as I told you, for any unknown, you just use the concept integral minus infinite to infinite fx dx on the function is named as px here. The integral px dx must be equal to 1. Okay, now generally the integral minus infinite to infinite, but here x is in the what range? X is in the range 1 to 4. So integral 1 to 4 px dx. Okay, that is Cx square. This must be equal to 1. Okay, that means C x square integral will be x cube by 3, limit 1 to 4. You have to equate this to 1. Okay, so C into upper limit 4 cube 64, lower limit is 1, divide by 3 is 1. So what is going to be the value of C? This cancels as how much? 63 by 3, 21. So C is actually 1 upon 21. Okay, now the rest of the calculation I will do here. What is the probability? X lies between 2 to 3. That is 2 less than equal to x less than equal to 3. Probability that a random variable lies between a to b is integral of the PDF from a to b. Integral 2 to 3 fx dx. Integral 2 to 3 fx. What is the PDF function? Cx square dx. Okay, where c value is known to me. What is the c value? 1 by 21. X square integral x cube by 3. Limit from 2 to 3. This again becomes 3 into 21, 1 by 63 outside, 3 cube 27, minus 2 cube 8. So answer is actually 19 is divided by 63. 19 by 63. Yeah, Samukha also gave the same answer, 0.3015. Okay, right. So rounded off to 3 decimal place, I will write down the answer as approximately how much you are going. I will not calculate. I'll just take your answer 0.3015. So I will approximate to 0.302, 3 decimal place. 0.302. 0.302. Okay, that's the answer. Anyways, next question. Okay, so a fundamental one only, a 2 mark question, but fundamental only. All right, very easy. So I told you that sometimes you will get direct property question as well. There are 2 random variables, okay, which are linearly related to each other. Y equal to 2x plus 3. Okay, in that case, I told you, what about mean of y? I will write down both the things here. Mean of y is 2 mean of x plus 3, aex plus b. Variance of y is given by what formula? Variance of y is 2 square into variance of x. That's it. Plus 0. The constant does not have any variation. Okay, so the answer, okay, the question here is telling, let sigma x square and sigma y square denote the variances of x and y. What is the correct relation? Okay, so the variance of y, sigma y square, is 4 times the variance of x. Option number B. Option number B. Yes, Bhanu, correct. Very straightforward it is, option number B. Okay, right. Okay, consider two statements. There exists a random variable. Okay, GATE CSC 2-mark question 2021. There exists random variable x and y such that expectation of x minus ex into y minus vy, that is known as covariance between x and y whole square, is greater than, okay, variance x into variance y, variance x into variance y. Okay, this is absolutely wrong, because I told you this will always satisfy less than equal to variance x, variance y. Okay, the Cauchy-Shaw's inequality. For all random variables, covariance is defined as expectation of, no, this is clearly wrong. Okay, the expectation of, not modulus x minus ex, directly x minus ex into y minus ey. Both of the statements are wrong. Okay, both are false. Option number A here. Okay, both are wrong, so correct answer you have to choose is option number A, right? Yeah. Okay. Yes, Amuka, correct. Both false. Match up also correct. Both false. Next question. Let x and y be random variables, not necessarily independent, that take the real values in the interval 0, 1. Okay. Let z is equal to xy and let the mean value of x, y, z be x bar, y bar, z bar respectively. Which one of the following statements is true? Which one of the following statements is true? Okay, GATE 24 CS 2-mark question. See, x and y are random variables which are not necessarily independent, but they take the real values in the interval 0, 1. Okay. Let z is xy, okay, and x bar, y bar, z bar be the mean value, expectation value. Okay, now you see whether z bar is equal to x bar, y bar, they are not necessarily independent. See, let me tell you what is z bar. Z bar means expectation of z, mean value. Okay, expectation of z means what is the z but? Z is x into y. That means expectation of x into y. Now, this is equal to ex into ey. Okay, or let me explain it this way. This term comes up where? This term comes up in the variance formula, right? Covariance formula. Now see, what is the covariance formula? Covariance is given by expectation of xy minus expectation of x into expectation of y. That was the final covariance thing. Okay, now expectation of xy means z bar. Expectation of x means x bar. Expectation of y means y bar. So z bar minus x bar, y bar. This is the covariance value. Okay, but as I told you, covariance may be positive, may be negative, may be 0. Okay, this may be greater than 0, this may be equal to 0, this may be less than 0. Okay, that means z bar may be less than equal to x bar, y bar, may be greater than equal to x bar, y bar. Okay, anything is possible. Okay, equal to the definitely not correct here, because they clearly told they are not necessarily independent. If they were independent, answer will be A. So definitely answer is not out of A, B or C. Okay, then what is left? D. Now, what is the simple logic? It's a simple logical question for 2 marks. D. Z bar is less than x bar. See, simple reasoning. X and y are random variables which takes the values between 0 and 1. Okay, so see, the y I can say belongs to 0, 1. That means I can write this way. Y is between 0 to 1. Correct? Y is between 0 to 1. Okay, now z is x into y. Now y maximum value is 1. Y maximum value is 1. That means what is the z maximum value is x. If you put y equal to 1, that means z is less than equal to x. I can say na, because y is 1 or below it. Okay, so z is less than equal to x, and if z is less than equal to x, the expectation of z is also less than equal to expectation of x. Okay, that means correct answer is option number D. Anyways, I told you, okay, A, B, C is not correct, so only D was left, but this is the logic of commenting on the answer. A logical question, 2 marks. Okay, but logical question more or less, I would say. Okay. Okay, let's go to the next question. Okay. Consider the discrete random variable x and y with the probabilities as given. Okay, given x equal to 1, so probabilities, joint probabilities of x and y are given. Gate 25 double even mark question. Joint probabilities of x and y are given. Now given x equal to 1, what is the expected value of y? I will tell you a simple logical method of solving it, then I will tell you the actual formula method also. See, method number 1, okay, a simple one. Given x equal to 1, now it's like conditional probability. When anything is given, okay, that becomes your sample space, because if they say x equal to 1, they clearly mean x cannot be 0. So these two events are discarded then. These two events are discarded. Okay, so only these two are possible. Okay, these two are possible. So tell me, given x equal to 1, okay, they've only given about x. Okay, what about y? Y may be 0 or 1. Okay, I want the expectation of y. Let's talk about probability of y. Okay, if x is 1, y can take the value 0 or 1. Okay, but whenever x was 1, y take the value 0 or 1 with equal probability. With equal probability. Okay, with equal probability. Now, if you see, sum of all probability is always 1. 1 by 4 plus 1 by 2. Okay, 1 by 8 plus 1 by 8 is again 1 by 4. So 1 by 4 plus 1 by 4. 1 by 2 plus 1 by 2, 1. Sum of all probability always 1. But as I am telling you, if x is equal to 1, your only sample space is, this is given. This is given, and whatever is given, this becomes your new sample space. Okay, anything will happen within it, not outside it. Okay, not outside it. Okay, so you have to only talk about two things now. What is the probability x equal to 1, y equal to 0? What is the probability that x equal to 1 and y equal to 1? X is anyways 1. Okay, but what about y equal to 0 or 1? Okay, see, whenever x equal to 1, y equal to 0 or 1 were happening with equal probability. With equal probability. Okay, so both of them must be equal. Okay, and also summation should be 1, because sum of all probability is 1. So if you want two variables, if you want two values whose sum should be 1 and they should be equal, so what are the values? 1 by 2 and 1 by 2. 1 by 2 and 1 by 2. Okay, that means both of them are equal to 1 by 2 each. Both of them are 1 by 2 each. Okay, that means I will rewrite the statement here. Y can take two values, 0 or 1. What are the probabilities? 1 by 2, 1 by 2. Now, what is the expectation of y? Okay, what is the expectation of y? Same logic, every value into probability, 0 into half plus 1 into half. Net answer is 1 by 2. Net answer is given by 1 by 2. Net answer is given by 1 by 2. Okay, net answer is simply given by 1 by 2. Tell me if there is any sort of confusion here. Okay, 1 by 2, that is option number B. Option number B. D is missing here, but not required. That is not anyways correct. D option has missed here. Yashwant, not 8 is going to be B. Right. So see, if you want the actual formula method, the question is expectation of y given x equal to 1. Given x equal to 1. Now, expectation formula is given by a summation formula, right? Is given by a summation formula. Okay, what is that summation formula? Okay, what summation formula? It is about calculating the PMF of y, okay, summation of y into PMF of y. Okay, what about the which PMF of y? PMF of y given x equal to 1, okay, divided by the probability that x equal to 1. Okay, divided by the probability that x is equal to 1. Okay, divided by what is the probability that x equal to 1. This is what is conditional expectation. Now you see, if you have to solve it by the formula, okay, if you have to solve it by the formula, how many values y can take? Y can take the two values. Okay, what are the two values? Summation for all value of y. Two values are, okay, see, I'll write it this way, this one. Okay, it will be then equal to summation of probability y intersection with x equal to 1 divided by the probability x equal to 1. Okay, now I will apply the conditional probability formula. Okay, P of A given B, P of A intersection B divided by PB. Okay, P of A intersection B divided by PB. If you want for more clarity, I will write down the formula a little bit more clear. Okay, P of y, as I already told you, what is the meaning of P of y? Probability y takes the value y, given that x equal to 1. Okay, given that x equal to 1, whatever x value is given. Okay, now I will write it. This is summation of probability y equal to y intersection x equal to 1 divided by the probability that x equal to 1. Okay, now what are the different values of y? The first value of y is 0. Okay, 0 into anything will be 0, but for your clarity I will write down. Okay, 0 into what probability will come? Probability y equal to 0 intersection x equal to 1. Okay, plus the next value of y will be 1. The next value of y is 1. So now 1 into probability y equal to 1 intersection with the x equal to 1. Okay, now whole divided by the probability x equal to 1. Okay, now you see. Okay, the first term is 0. Okay, next is probability y equal to 1 intersection x equal to 1. Y equal to 1 and x equal to 1, 1 by 8. So 1 into 1 by 8. What is the probability that x takes the value 1? So now when I say x takes the value 1, okay, that means I only care about x equal to 1. So what about y? What about y? If x equal to 1, y can be 0 or y can be 1, anything. So denominator will have two cases further. Okay, two cases further. Now x equal to 1, y equal to 0. X equal to 1, y equal to 0. And x equal to 1, y equal to 1. So these two probability, 1 by 8 and 1 by 8 will come. Now 1 by 8 upon 2 by 8. Net answer 1 by 2. Net answer 1 by 2. This is what is known as the conditional expectation. The conditional expectation formula. Okay, but I have solved it by simple logic. Let me know any doubts, any place. All right, Abhishek. Yes, definitely I'll try to plan. Okay. All right, guys. Okay, so this is the answer. This is the answer. Okay. Then next question. All right, before the next question, an important update, guys. Yes, for all the GATE 27 aspirants, a very big announcement. Yes, the first offline course, the first offline batch for GATE ECEE, okay, for GATE 2027, okay, by OM Institute has been announced. Yes, okay, the first offline batch starts 26th of February. The first offline batch at our Hyderabad center, okay, starts 26th of February. Okay, so yes, interested students planning to prepare for offline for the next year for GATE 27, okay, can note down this important details, or for any query you can contact our support numbers or you can visit our website. Next. Let x be a discrete random variable that is uniformly distributed over the set, okay, minus 10, minus 9, etc., up to 10. Which of the following random variable is or are uniformly distributed? A good question, okay, a good conceptual question, MSQ question, 1 mark only, okay, but a good question for 1 mark, I would say. Okay. Okay. Yeah. If you're specifically targeting GATE TA paper, Abhishek, definitely this conditional expectation, variance, and all joint PMF, PDF are going to be actually important for you. Okay, guys, yeah, let's have a look into it. So, what is the question here? X be a discrete random variable that is uniformly distributed over this set. Now, first of all, if any discrete random variable is uniformly distributed, okay, what is the meaning of uniform distribution? Means uniform PMF. It will have uniform PMF or uniform probabilities. Okay, uniform probability. What does it mean is if x is uniform, what are the values x can take? X can take the value minus 10, minus 9, etc. up to 0, etc. up to 10. How many values? Total 10 positive, 10 negative, and including origin, total 21 values are allowed here. How many values x can take? X can take total of 21 values. Correct, na? How many values x is able to take? X is able to take total of 21 values. Okay, so because x is uniform, I told you uniform means uniform PMF. So what is the PMF? okay, p of x, okay, the p of x or will be constant. And what about constant? If you have to divide all probabilities equally and the sum of probability has to be 1, the PMF will be 1 by 21. Simple. The PMF will be 1 by 21. Okay, for x equal to any of these values up to 10. Okay, so that every value takes equal probability 1 by 21, and since there are 21 values, you add up, okay, all the values, okay, you'll get the total probability as 1. Okay, this is the uniform PMF. Now, which of the following random variables is or are uniformly distributed? X square, x cube, etc. Now, you see, dear, if you want to talk about x square, if I start with this option number A, y is equal to x square, whether it is going to be uniform or not. Let's check whether y equal to x square will be uniform. So, what are the values taken by x square? Now, when you square minus 10 and 10 will become one value. Okay. Minimum value will be 0 square, then 1, then plus or minus 2 both 4, etc. up to minus 10 or 10 whole square 100. But the point is, my question is not about the values, whether it is uniform. So, if I ask you what is the probability y takes the value 0, y will be 0 if x is 0. But if I ask you what is the probability y equal to 1, the probability y equal to 1 means x equal to 1 or x equal to minus 1. It is associated with two value. Okay. Now, what is the probability x equal to 0? Probability for any value of x is 1 by 21. But probability x equal to 1 or minus 1, two values are coming. Okay, if two values are coming, this becomes 2 by 21. So, uniformity is broken here. Uniformity means uniform PMF. Every value should have equal probability. Okay, this itself is clearly, okay, non-uniform. This is clearly non-uniform. Okay. Similarly, we'll try the option number B, that is x cube. Okay. Which of the following is or are uniformly distributed? Definitely A is not correct. Okay. What about B? Y equal to x cube. Now, cube, okay, positive and negative numbers will have different cubes only. Okay. Minus 10 cube, minus 1000, etc. up to 0 cube. Okay. And etc. up to again 10 cube, which is 1000. Okay, so here every value of x associated with the different value of cube, right? Now, what is the probability that if I ask you y equal to, what is the probability that y equal to 0? Okay, or I can put down the simple logic. Every value of x, okay, leads to distinct values of y. Okay, probability PMF of y will be constant. What constant? 1 by 21. Okay, again all 21 values are coming and the probabilities will be equal 1 by 21. That what went missing here? Okay, you see here, okay, two different values of x, two distinct values of x were taken. Okay, two distinct values of x gives one single value of y. One single value of y. That means what is actually happening here? Many to one mapping. Many values map to one value of y. Okay, many to one mapping. But what is happening here? Okay, every value of x. Okay, every value means, again I'll be more specific here. Okay, if there is every distinct value of x, it leads to distinct values of y. Distinct values leading to distinct values of y. One to one mapping. This one has one to one mapping. Okay, that is why y again will take 21 different values and probability of every value will be equal to probability of the x values only, 1 by 21. Again, if I come to C, so this is going to be uniform. B answer is correct here. But it is a MSQ question, you can't stop here. Okay, you have to talk about C and D as well. Okay, what about x minus 5 whole square? X minus 5 whole square. Now you see very clearly, okay. Okay, what is going to happen here is, okay, x takes the value from minus 10 up to 10, correct? Option number C is x minus 5 whole square. Now, x minus 5 whole square. What about x minus 5 if you see now, first of all? x minus 5 will be minus 15, minus 14. Then there will be this value, minus 5, and it will go up to the value 4 and 5. That's it. X minus 5 will stop at 5. Okay, but still there is minus 5 and 5. Okay, minus 15 is unique. Okay, there is no plus 15 there. Okay, so minus 15, this is unique. But minus 5 and 5, okay, this is repeated. Okay, so again there is many to one mapping, two different values of x giving one single value of y. Okay, again what it is, one to one or many to one? Many to one. So it cannot be uniform. It cannot be uniform. Why? Because if I ask you probability, this is y, y is x minus 5. If I ask you y equal to minus 15, it means probability x equal to minus 10. That is only associated with a unique value of x. But if I ask you probability y equal to how much? Probability y equal to how much? Now when I'm going to take square, okay, repeated means repeated in the terms of square. See, what I meant here is minus 5 or plus 5 repeated means in terms of square, because what is y is not x minus 5. I'll write down the complete data. X minus 5 square, minus 15 square 225, minus 14 square 196, but minus 5 square 25, and again 5 square 25. This is what I meant by repetition. Okay, same value. Okay, because of two different values of x, many to one mapping. Okay, but this one was unique. This one is unique. This is appearing 1. So if I ask you the question now clearly, what is the probability y is 225? It means probability x equal to minus 10. It is because of x minus 10. But if I ask you what is the probability y is 25? Now y is 25 if x is how much? 0 or 10. Probability x equal to 0 or 10. Okay, two different values probability, 2 by 21. One single value probability, 1 by 21. Non-uniform. Many to one mapping, non-uniform only. Many to one mapping. Understand, it's a conceptually it's a good question. Okay, that's why I'm explaining it in detail. Okay, and then what about the D answer? Okay, again for your reference I will write down all the x values which are given here, and D option is talking about x plus 10. X plus 10. So plus 10 means first value itself is 0. Minus 9 plus 10, 1. This is 10. This goes up to 19. This goes up to 20. Now all 0, all positive values. So x plus 10 whole square. The option number D says that y is x plus 10 whole square. 0 square, 0. 1 square, 1. 10 square, 100. Okay, 19 square, 361. 20 square, 400. Any repetition? Repetition will occur if there was a minus a and plus a, and when you square it becomes same. Okay, here there are no negative values. Okay, when you take x plus 10, all values are positive or 0. So no repetition here. Okay, no repetition means what is meant here is again 1 to 1 mapping, and 1 to 1 means uniform only. Okay, 1 to 1 means again you will get uniform. Because if I ask you what is the probability of any value of y, okay, will be constant. Okay, and that will be 1 by 21, because 21 different values are obtained here. Okay, the 21 different values are obtained here. Okay, so D is uniform and B was uniform. Okay, B and D, these are the two correct answers. Okay, so you see, conceptually it is a good question. You should understand, what is the meaning of the question and how do you prove whether any given random variable is uniform or non-uniform. Given x was a uniform random variable, which of the following is or are uniformly distributed? Okay, all right. Anyways, so hope you have learned something from this question. Let's go to the next question. Okay, binomial distribution. Now you will find common questions on binomial and Poisson distribution. Let's have a quick review of the binomial distribution. See, whenever you talk about binomial distribution, I start with the example like a coin, okay, which can have, okay, if you talk about a coin, it may have two outcomes, head or a tail. Okay, or any event, okay, which has two possible outcomes. Okay, success or failure. Suppose head is success. You can also call tail as success, no problem, but just as a reference, as a convention, let's say getting the head on a coin is a success. Okay, if you don't get head, you get tail. That means failure. So in any part, in any event you do, you may be successful, you may be failed. Like dice. Dice have 6 outcomes. Okay, will dice come under this? Dice have 6 outcomes. I want to talk about those outcomes which have only 2 outcomes, 2 possibilities, success or failure, known as Bernoulli's. Okay, but suppose you are playing the game of Ludo, and in the game of Ludo, what is the first thing you want in the dice? Is a 6. Is a 6. So whenever you roll the dice, you only think whether 6 has come or 6 has not come. Okay, you can divide the outcomes as 2 parts. Okay, 6 meaning success. Anything other than success, failure. Okay, so then I have defined a parameter here, P. P means probability of head, or in general probability of success. Like for a dice example, if I ask you what is a P, for this dice example, if I ask you P, probability of success, probability of getting 6, 1 by 6, 1 out of total outcomes. Okay, if I talk about fair coin, fair coin means what is the probability of head? 1 by 2. Okay. So let's generally consider probability of head is P. And now when such an event is done repeatedly and independently n times, okay, when such an event is repeated for n times, in some of the times you may be successful, in some of the times you may be failure. That means sometimes you will get heads, sometimes you will get tails. Okay, how many times you were successful? How many times you got heads? Let x be the number of heads obtained. Okay, this x will be a binomial random variable. Okay, how many times heads can be obtained? Worst case 0, every time tails, or 1 head or single head, or maximum to maximum what can happen? Maximum to maximum n heads. Okay, that is the best possibility. Na? So minimum 0 heads and maximum n heads. Okay, now x is a binomial random variable with the parameters of n and p. Okay, what is the PMF? PMF is given by, I'm not deriving it again, the PMF direct formula turns out to be NCK p power k q power n minus k. PMF, P of A. P of k means probability that x takes the value k. Mean, I told you how do we calculate mean, summation of x into PMF. Means turns out to be the formula n into p. Variance for the binomial turns out to be the formula np into 1 minus p. Means npq, where what is q? Q means 1, or you can say q is the probability of failure. Probability of failure means 1 minus probability of success. That I have called as q here. Okay. So see, that was a direct question in gate 21 mechanical 1 mark. What is the mean and variance of binomial? It is np into np 1 minus p, option number A. Now let's go to some more numerics also. Okay. For a given biased coin. Now see, what is a fair coin, you know? See, I'll write down one formula especially for fair coin. See, if it is fair coin, because in binomial fair coin questions are very common. So if it is a fair coin, as I already told you, what about P? 1 by 2. So what about Q? Q means 1 minus P, that also becomes half. So in such a case, what is the PMF? In such a case, the PMF is given by P of x given by NCK p power k q power n minus k. But when I put down the value of p and q, both are half. So half power k and powers if I add, because half is common, the total power will be n. It is then given by nck half power n. So that can be a formula, okay, if it is specially a fair coin. Okay. Now the next question says that a biased coin, not fair. Biased means unfair. Biased towards something. Probability of head and tail are not equal. Probability of head not equal to the probability of tail. So if they are not equal, then they have to mention what is the probability. Correct, na? The probability that outcome of a toss is head, yeah, this is given, is 0.4. So they have given P means the probability of head is 0.4. Is 0.4, correct? Now next, this coin is tossed 1000 times. Okay, so how many times the coin is tossed? That is known as the value of n. N is equal to 1000. Let x be the random variable whose value is the number of times head appeared. Okay, so what is x? When you're counting number of heads, whenever you're counting number of success, as I told you here also. Okay, when x is a binomial random variable, when you're counting number of heads, okay, number of heads, or in general, number of success. When an activity is done n times, how many times you are successful? Okay, that count of number of success is a binomial distribution. Okay, so x is the binomial random variable. Okay, n value is 1000. What is the standard deviation? Direct question, 1 mark question. Just you have to understand the language. Okay, what is the standard deviation? standard deviation of x sigma. Okay, standard deviation means root over of variance. What is the variance formula for binomial? Under root np1 minus p. The variance formula is np1 minus p. The standard deviation is root over of this. That is under root of 1000 into probability 0.4 into 1 minus p will be 0.6. Okay, how much it becomes? 24.24 into 1000, 240 under root of 240. Under root of 240. Okay, so NAT question, let's write down the answer approximately, rounded off to 2 decimal places. Anybody with the answer as of now? So it's again a direct formula question only. 15.49. Okay, dear. $15.49. Yeah, next question. A remote village has exactly 1000 vehicles. Okay. Yes, Bhanu, correct. A remote village has exactly 1000 vehicles with sequential registration numbers starting from 1000. Out of these vehicles, 30% are without pollution clearance certificate. Further, even and odd number vehicles are operated on even and odd number dates respectively. Okay, if 100 vehicles are chosen, okay, at random on an even number date, okay, the number of vehicles expected without pollution clearance. Okay, out of these vehicles, 30% vehicles are without pollution clearance. Now see here, what can happen? Okay, if you talk about a single vehicle, okay, think about a single vehicle. It's a civil question. Okay, but a direct binomial question. See, if you talk about a single vehicle, what can happen? Single vehicle that is in front of you may have the pollution clearance or may not have the pollution clearance. Okay, right now we want how many vehicles are there without pollution clearance. Okay, the number of vehicles expected. Expectation means mean. Expected value means mean value. Okay, so any single vehicle, it may be without the pollution clearance, okay, or with the pollution clearance. Okay, that means like head or tail. Okay, any event may give you success or may give you failure, just like head or tail. Okay, any single vehicle falls under this category, correct? Now how many vehicles are to be chosen? 100 vehicles. Okay, how many vehicles are to be chosen? 100. But what is P in any binomial? P means probability of success. Probability of a vehicle without pollution clearance, 30%. Okay, is 30%. That means 0.3. Okay, now how many vehicles you want to observe? 100 vehicles you want to observe. What is the last statement? If 100 vehicles are chosen at random on an even number date, what is the number of vehicles expected without pollution clearance? Okay, let n is 100 vehicles. Okay, x is the number of vehicles. Let x be the number of vehicles which are without the pollution clearance. Number of vehicles without the pollution clearance. Okay, that means like number of heads. Okay, like number of heads, what is the expectation of x? Okay, this is again like number of heads, number of success obtained, number of heads. How many vehicles can be there? Okay, without pollution clearance, maybe 0 vehicle or maybe all 100, up to all 100. I am observing 100 vehicles. Okay, what is the expectation formula for binomial? N into P. Because whenever you are counting number of heads or number of success, whenever you are counting number of success, it becomes binomial in nature. What is the expectation? Expected such vehicles is n into p. Okay, it is given by the formula n into p. N right now is 100 and p is how much? 0.3. Net answer is 30. The net answer is 30. It is about understanding the language. Correct answer is B, that is 30. Okay, next question. Yes, Bhanu, correct. Yeah. The probability of a student missing a class, gate instrumentation, 2 marks. Easy question for 2 marks. Okay, the probability of a student missing a class is 0.1. In a total number of 10 classes, what is the probability? Student will not miss more than 1 class. Okay, will not miss more than 1 class. Okay, so how many classes a student can miss in a span of 10 classes? See, if you talk about a single class, okay, student may miss the class or student may attend the class. Again, right now the question is about missing the class, so I'll call the missing as success. Again, like head or tail, there is success or failure. Okay, what is the probability of success? P means probability of success. Success means missing a class. What is the probability of a student missing the class? 0.1. Okay, then you have to observe 10 classes in a span of 10 classes. Okay, total if there are 10 classes, okay, let X be the number of classes missed, like number of heads, like number of success. Okay, number of success always becomes what type of parameter? Binomial parameter. Number of success always becomes a binomial parameter, correct? Number of success is what? Is a binomial parameter. Okay, now what we want? We want the probability that student will not miss more than one class. So how many class can he miss? Okay, probability not miss more than one class. Okay, so miss one class or zero class. Probability X equal to 0 or 1. Okay, he will not miss more than one class. Okay, so he is allowed to miss how many class? 1 or 0, not more than 1. Okay, not more than 1. Okay, so 0 or 1. Okay, now what is the probability of 0 or 1? See, what is the PMF, PK formula? PK formula means probability X equal to K, which is given by how much formula? Which is given by the formula NCK P power K Q power N minus K. Okay, so what is the value for X equal to 0 here? If I put K 0, N is 10 here, 10C 0, okay, which will be simply 1. What is the P value? 0.1. 0.1 power 0, okay, 0.9 power 10. Next calculation will be 10C1 if you put K equal to 1. 10C1 P power 1, 0.1 power 1, 0.9 power 10 minus 1, that is 9. So answer has to be 0.9 raised to the power 10 plus 10 into 0.1 into 0.9 raised to the power 9. 10C1 is 10, 0.1 power 1. Okay, approximately you have to tell me how much is the value turning out to be. Round it off to how many? 2 decimal places. Okay, 0.9 power 10 plus 0.9 power 9. That is what you are required to calculate. Okay, how much it is turning out to be? Power 9, 0.9 plus 1. 0.38 is what I am getting. 0.73, no? Just recheck it, Bhanu, once. Yeah. No. Correct. Some error. Yeah, 0.736 or 0.74. Rounded off to 2 decimal place. 0.74. Yeah. Yeah, 0.736. 0.74. We can write down the answer. Okay. Okay. Next one. Okay. Now, gate 22, civil 2 marks question. Okay, this is a good question. A pair of 6-faced dice is rolled twice. A pair of 6-faced dice is rolled twice. What is the probability that sum of the outcomes in each roll equals 4 in exactly 2 out of the 3 attempts? So, see, a pair of 6-faced dice is rolled twice. Okay, probability that sum of outcomes in each roll equals 4 in exactly 2 out of 3 attempts. Okay, so what attempts they are making? They are making a single attempt where what is there in a single attempt? Let us talk about a single trial first of all. In single attempt, okay, what is happening? A pair of 6-faced dice rolled twice. A pair of dice I will write. It is normally 6-faced only. A pair of dice is rolled twice. Okay, and then you want probability that sum of the outcomes in each roll. Sum of the outcomes in each roll equals 4. Okay, so now whenever a pair of dice is rolled twice, what is the value of the sum on the dice? Okay, or simply let me write it as sum of outcomes. Pair of dice means 2 dice. Okay, so what is the minimum sum? 1 plus 1. The minimum sum is 1 plus 1, that is 2. Okay, then it may be 1 plus 2, which is 3. And then the next sum will be 4, like 1 plus 3 or 2 plus 2, etc. The maximum sum will be 12. The maximum sum will be 12. 6 plus 6, na? Okay, 6 on each dice. Now, I can write down the sum as 2 cases. We want the sum of outcomes on each roll to be equal to 4. So, I can say this way. The sum can take many values, but sum may be equal to 4 or sum not equal to 4. This is what will happen in single attempt. Okay, so in any single attempt, you may have success or you may have failure. If you get sum equal to 4, that is success. Now, I want to calculate what is the probability of success. That parameter is P always. What is the probability of success? Probability of success means what is the probability that you get sum equal to 4. Okay, how much is the probability for sum equal to 4? See, sum equal to 4 means how can you get the sum equal to 4? How can you get the sum equal to 4? 1 comma 3, 2 comma 2 and 3 comma 1. Any other possibility? Tell me if there is any other possibility. On 2 dice, if you want sum 4, these are the possible outcomes of the 2 dice, 1 or 3, 2, 2 or 3, 1. That means there are total 3 possible outcomes divided by 36. Divided by 36, because whenever you talk about 2 dice, the sample space is given by 6 square, that is 36. Okay, so probability of success here is 1 by 12. So Q means probability of failure, 1 minus 1 by 12, that is 11 by 12. Okay, now how many attempts I make? 3 attempts. Okay, n equal to 3 attempts will be made. Okay, and what is x? X is the number of success obtained. Okay, x is the number of success. Number of times the sum equal to 4. Okay, number of times. How many times you want sum? You want the sum equal to 4? Exactly 2 out of 3 attempts. Exactly 2 out of the 3 attempts. Okay, so question is, what is the probability that x equal to 2? Okay, x equal to 2. So again, what is the pk formula? Binomial PMF formula. Pk means probability x equal to k, and that means again the formula nck, p power k, q power n minus k. So what is n here? 3. 3c2, I want the x equal to 2. P power 2, p is 1 by 12, 1 by 12 power 2, q is 11 by 12, 11 by 12 power 3 minus 2, which is 1. So 3c2 is 3. Then numerator will be 1 into 11 divided by denominator will be total 12 cube. 12 power 2 and 12 power 1. Total 12 cube will be the denominator. Okay, so net answer, okay, is 33 divided by 12 cube. Now let us check the correct answer here. Okay, Bhanu and Ganesh have given the answer 0.019. Okay, let's check it out once quickly. Yeah, 0.019 is the correct answer. They have mentioned up to 3 decimal places, correct? 0.019. 0.019. Okay, gate 22, 2 marks question. Okay, dear. Before the next question, next important update for you. Okay, before the next question, another next important update for you. Right, guys? So, guys, I mentioned about offline course, the first offline course at our Hyderabad center starting from 26th February. But in case you can't travel to Hyderabad, or if you're a college going student, cannot manage offline but still want the gate preparation for gate 27, 28 under the Om Institute faculty team, the best for EC and EE, the first online live course is now starting. So, everybody who's outside Hyderabad or who is in college going right now, they can, attend this online live course. Okay, so because it's a live course, you still have a feel of, direct interaction with the faculty on spot through the chat box. Okay, the first batch starts 2nd February. Okay, for gate 27, 1 year validity, this is the fee mentioned. For gate 28 with 2 year validity, this is the fee mentioned. Okay, the platform will be Om Live app. And if you register till 20th January 20, you get additional 20% discount on the fees mentioned, as well as as well as 1 month extra validity. Okay, that means a 1 year course, a 12 months course will become 13 months, 24 will become 25. Okay, you just have to use the code OHM-GATE20 for this. OHM-GATE20, OHM-GATE20. All right, next question for you. Next question for you. Now see, a machine produces defective components with the probability 0.015. The number of defective components in a packed box containing 200 components produced by the machine follow a Poisson distribution. What is the mean and variance of the distribution? Now listen to this point very clearly. Okay, what is the condition here? A machine produces a defective component. So if you talk about any single component, okay, if you talk about any single component, let me tell you quick points here. If you talk about any single component which is produced by the machine, okay, that may be defective or non-defective. That may be defective or non-defective. Correct? Now that is what can happen with a single component. It may be defective, it may be non-defective. Defective means success or failure. Again, so it again looks like a binomial problem. Okay, it again looks like a binomial problem. Okay, it again looks like a binomial problem. Okay, where P means probability of success. Listen to me, they have clearly mentioned Poisson, but just one point I want to add here. Probability of a defective item 0.015. 0.015. Okay, or it is like 15 by 1000. 15 by 1000. Okay, now if you have n equal to 200 components, n equal to 200 components, n equal to 200 components. Out of the 200 components, some components may be defective, some may not be defective. Let x be the number of defective components. Okay, x be the number of defective components, which means number of success, which is normally counted as binomial. Okay, or Poisson. See, what is the condition here? In this question, what is the condition? The number of components is not like 5, 10, 20. It's some large value and the probability is 15 upon 1000. Okay, it's small. The probability is very small. Only 15 out of 1000 components may be defective. Okay, whenever the n becomes large and the p becomes small, the binomial converges to Poisson distribution. Given by what formula? Given by the formula e power minus lambda, lambda power k divided by factorial k. Okay, where k can take any value from 0 to n. Okay, same, the x or k values are 0 to n. E power minus lambda into lambda power k upon factorial k, where what is lambda? Lambda is known as the mean. Lambda equal to n into p, known as the mean. Okay, but now probability is very, very small. Na? Okay, so 1 minus p is approximated as 1, almost equal. Okay, so that is why the variance is considered here as NP only. So lambda is not only the mean, is also the variance. Variance is also approximately lambda. Okay, now in practice, see, the previous question clearly mentioned it is Poisson. Okay, it is clearly mentioned Poisson. So what is the mean and variance formula? Okay, it is NP, variance also given by NP. So what is going to be the NP? Okay, what is going to be the NP? The mean and variance both are equal to lambda. Lambda means NP, n is 200 and p is 0.015. Direct formula question, this becomes 3. So both of them are 3 each, 3 and 3 respectively. 3 and 3 respectively. Direct question for 1 mark, gate 23 mechanical. Okay, so if nothing is mentioned, so as a rule of thumb, if probability is small like 1 by 100 or 1 by 1000, is in the order of 1 by 100, 1 by 1000, and the lambda less than equal to 5, n into p less than equal to 5, normally Poisson is used. To see here, what was the lambda? What was the lambda? 3. That is why, okay, when probability is small and lambda less than equal to 5, as a rule of thumb, we follow Poisson. Rule of thumb means, of course, something which cannot be derived. I cannot derive and say here you use binomial, here you use Poisson, but after practicing several problems, we have made a rule of thumb that yes, for these values, okay, the Poisson will give you more easier calculation as compared to binomial. You can still use binomial, okay, but Poisson will be more handy. But anyways, this was a direct statistical question, mean and variance. Next question, easy only. Okay, 2 marks question, but directly on the probability formula. Directly on the probability formula. Come on, do it. Let a random variable x follow Poisson distribution such that probability x equal to 1 is equal to probability x equal to 2. Now see, what is pk formula I told you? Pk means the probability x takes the value k, and which is given by the formula e power minus lambda into lambda power k divided by factorial k. So what is the meaning of this statement? Probability x equal to 1 means e power minus lambda power 1 upon factorial 1 is equal to probability x equal to 2, that is e power minus lambda power 2 upon factorial 2. Okay, e power minus lambda cancelled from both sides, right, left side, what is there? Lambda by 1 is lambda. Right side, lambda square by 2 factorial means lambda square by 2. Okay, right. So, what is the value of lambda? Okay, from here you will get lambda either 0 or lambda equal to 2. 0 is anyways not possible. Mean cannot be 0. Okay, mean is n into p and any of them cannot be 0. Otherwise, there is no event only. So, what is the value of lambda? It will be 2. Lambda will be 2. Now the question, what is the probability that x is equal to 3? Will be e power minus lambda is 3 into 3 raised to the power 3. Sorry, lambda was 2. E power minus lambda is 2 into 2 power 3 divided by factorial 3. 2 power 3 means 8, 3 factorial is 6 into e power minus 2. Okay, and the final answer 4 by 3 e power minus 2 has to be calculated. Calculate and round off to 2 decimal place and give me the answer. Okay, Ganesh, great to know that you're learning. Point 18, just check out the values once. Yeah, 0.18. Bhanu says no. Anyways, probability cannot be greater than 1. Bhanu, just recheck the numbers. Okay, what I got? 0.18. Okay, just recheck the calculations and let me know whether this is right or wrong. Okay, next question by that time. Okay, get 2 mark question here. Vehicular arrival at an isolated intersection follows the Poisson distribution. The mean vehicular arrival rate is 2 vehicles per minute. The probability that at least 2 vehicles will arrive in any given 1 minute interval is how much? Okay, see here. Vehicular arrival at an isolated intersection follows Poisson distribution. Clearly, question is talking about Poisson distribution. The mean, okay, the mean arrival is 2 vehicles per minute. Okay, what is the mean? Lambda, it is 2 vehicles per minute. The probability, rounding off to 2 decimal places, that at least 2 vehicles were alive. Okay, that means I want the arrival of 2 or more vehicles in a given minute interval. That means x is greater than equal to 2. Okay, at least 2 vehicles. But x greater than equal to 2, okay, it can be how many vehicles? 2 or 3 or 4 or 5. Okay, it can be any number. So better, let's reverse it. Okay, x greater than equal to 2. So what are the values left? X equal to 0, x equal to 1. These two probability and subtract from 1. Reverse. Okay, probability of A complement is 1 minus probability of A. Okay, because these are the only two values left. Okay, because at least 2 means there will be many calculations. Now, what is the formula to be used? Again, pk formula. Pk means probability x equal to k and given by the formula e power minus lambda power k divided by factorial k. E power minus lambda is 2 into 2 raised to the power k upon factorial k. Okay, so for the first calculation, x equal to k equal to 0, e power minus 2 into 2 power 0 by 0 factorial plus e power minus 2 into 2 power 1 is divided by 1 factorial. Okay, this will be how much? 1 minus e raised to the power minus 2. 2 power 0 by 0 factorial. 0 factorial is also 1. This is 1. 2 by 1, 2. Okay, so net answer 1 minus 3 e raised to the power minus 2. 1 minus of 3 e raised to the power minus 2. Okay, we have to just write down the net answer. approx 0.59. Correct, Bhanu. Approximately 0.59. Correct answer. Sorry. Okay, approx 0.59. Correct answer. Next question. Gate 21 double E 1 mark question. Suppose that the probability that a coin toss shows head is P, okay, where P is between 0 to 1. Coin is tossed repeatedly until the first head appears. Now, event is done repeatedly till first success is obtained. Okay, this is a direct question, 1 mark. Okay, expected number of tosses required. Okay, 1 by P. Okay, a coin is tossed repeatedly till the first success is obtained, till the first head is obtained. Geometric distribution. This is a geometric random variable question. Okay, a coin, okay, with probability of head equal to P. Head again means success parameter. Just as an example, coin is taken. Okay, is tossed repeatedly and independently till a head appears for the first time. Okay, till a head appears for the first time. Okay. Some event is done repeatedly till you get success, till you get first success. Okay, because you don't know, na, you keep tossing the coin, where can head come? Okay, a coin is tossed repeatedly till a first head is obtained. Where can you get the first head? Possibility on the first toss. Suppose the x is the number of tosses required. Okay, x will be known as geometric random variable. Okay, where can you get the first head? You may get the head on the first toss. If you don't get the head on the first toss, you may get it on the second, or you may get it on the third, or you may get it on the fourth. Till, can anybody tell me where to stop this set? If I talk about worst case, unlucky situation, you keep on tossing, you keep on tossing, you keep on tossing, maybe 1,000 times, 10,000 times, 10 lakhs time, you are not getting a head. You are continuously getting a tail. I mean, it will have less probability of what I am telling, but it is still not zero, na? Anything which has even 0.01 probability or 0.00001 probability, we have to consider here. Okay, so it may be possible 1,000, 10,000, lakhs of time you have tried and you are only getting tails by chance. You are still not getting a head. Okay, so how many can be the number of times you toss so that you get the first head? Can't say. Okay, it goes up to, in general, infinity. In generalization, goes to infinity. Okay, PMF, okay, is given by the formula. Again, not deriving it, writing down the final formula. PMF, 1 minus k power k minus 1 into P. What is PMF? Pk, probability x equal to k. What is the probability that you get the head on the kth toss? Simple logic, na? Okay, this is the probability of head. But if the head is on the kth toss, all the before tosses were tail. All the before tosses were tail. How many tosses before? K minus 1. Okay, so k minus 1 times tail. Probability of a tail is 1 minus P. Okay, so 1 minus P power k minus 1 into P. That is the simple logic of writing down this PMF. Okay, on solving, the mean turns out to be 1 by P and variance turns out to be 1 minus P by P square. This was a direct question on the variance only, mean only, 1 by P. Correct answer is A. Gate 21 electrical 1 mark. Gate 23 electrical 2 mark question. The expected number of trials for the first occurrence of a head in a biased coin. Now, there is a biased coin, as I told you. Biased means unfair coin. Probability of head or tail will be different. How much different? Let's see. The expected number of trials for the first occurrence of head. Now, first success. Whenever you are talking about first occurrence of success, that distribution is geometric distribution, correct? Okay, and in the geometric distribution, what is the expectation? Expectation is given by the formula 1 upon P. Okay, and they have given the expected number to be 4, and that should be 1 by P. So what about P? P means 1 by 4. What is this P? This P means probability of head. So because it is a biased coin, probability of head and tail are different. Q will be 1 minus P. Okay, 1 minus 1 by 4, that is 3 by 4. This will be the probability of tail. Different probability for head and tail, unfair coin. Okay, biased coin. Okay, now the question is probability of first occurrence of head in the second trial. probability of first occurrence of a head in second trial. This is simply equal to, don't apply any PMF formula, simple direct question it is. What is the probability of first occurrence of head in second trial? So first head in the second trial. Okay, first head in the second trial. So what about first trial? Of course, first trial will be tail. Of course, first trial will be tail. What is the probability of tail? 3 by 4. And then a head will come, probability 1 by 4. So answer is 3 by 16. NAT question? Okay. Okay, this is gate 23 EE 2-mark question. 0.1875, 3 decimal places na, write down 0.188. That's it. That's it. Okay, next question. Okay, before the next question, the next important update for you. Yes, guys, if you are planning for the preparation of the AE exams, yes, the Telangana Genco Transco Discoms or the AP Genco Transcom Discoms, the new offline batch at our Hyderabad center starts 21st of January, both for AP Genco Transco Discoms and the Telangana Genco Transco Discoms. All right. Next one, the lifetime of a component of a certain time is a random variable whose PDF is exponentially distributed with parameter 2. Okay, the parameter of exponential distribution known as lambda, okay, is 2. Okay, so let's have a quick review of the exponential random variable. The exponential random variable has the PDF, which is an exponential function lambda e power minus lambda x for positive value of x. Okay, the mean of the exponential distribution is 1 by lambda. The variance is given by 1 by lambda square. Lambda is simply known as the parameter of the distribution, parameter of the exponential distribution. And one more important calculation, because there are repeated questions on this exponential random variable around this formula. Probability x greater than a will always be given by e power minus lambda. In fact, the previous question is on the same formula. Okay, what is the probability that its lifetime will exceed the expected lifetime? Expected lifetime means, okay, expected lifetime means mean lifetime. Mean means e of x, and as I told you, e of x is 1 by lambda, which is not required here. Okay, which is simply 1 by 2 if I want to write down the answer. Okay, but what is the probability that the lifetime exceeds the expected lifetime? What is the probability that lifetime means x? Okay, the lifetime suppose is x, exceeds means greater than the expected lifetime, greater than 1 by lambda. Okay, now probability x greater than a, I told you use this formula always. Probability x greater than a or greater than equal to a, anything okay, is e power minus lambda a. So it is e power minus lambda into a is 1 by lambda. So for such a question, even if lambda not given, no problem. Okay, because answer is simply e power minus 1, which will be approximately percentage or how many? 2 decimal places. So approximately 0.37 if you want to write for 2 decimal places. That's it. Correct, na? So that's a simple question. That's a simple direct question. So a quick review of exponential random variable is also presented here. Okay. Now let's have a quick review of uniform random variables. Okay, because questions sometimes can be on direct formula, but rather many questions indirectly use the uniform random variable. Okay, like uniform random variable I told in discrete distribution also. This one is about continuous. X can take any value between a to b. Okay, what is the meaning of uniform random variable? Again, the PDF is constant, uniform PDF. Okay, the PDF has to be constant over given range. So suppose x takes the value a to b, the entire values of a to b, the PDF is constant. The point is, will it take any constant? No. Okay, it has to be constant when x is between a to b, but will it take any constant? No. What we know is area under PDF is unity, na? What we always know, area under PDF is unity. Okay, area under PDF is unity. So what is the area under rectangle? height into base, height is k, base is b minus a, this must be 1. So k cannot be any constant, k is given by 1 upon b minus a, so that total area is 1. So putting down the value of k as 1 upon b minus a, the final PDF formula, final PDF is given by 1 upon b minus a, 1 upon, you simply remember like this, 1 upon length. Okay, when the variable is between a to b. Okay, the mean value is given by the mean, the middle point of the given interval. A and b is the given interval, the midpoint is a plus b by 2. Variance, you all know what is the mean variance formula. Solving for this PDF, the formula is written here. The variance is given by b minus a whole square divided by 12. Okay, the b minus a whole square divided by 12. One more important point for uniform random variable I would like to add here is, one more important point is, suppose if x is uniform, one simple point, suppose that x is uniform and suppose it is uniform in the interval -1, 7. Okay, what is the PDF of it? The PDF of it will be f of x is 1 upon length. That's what I told you. What is the length of the interval? -1 to 7, 8 units, 7 minus -1. So PDF you will write as 1 by 8. Whenever x lies between the given interval -1 to 7. This is the PDF. Now if I ask you the question here, what is the probability that 2 is less than equal to x less than equal to 5? Suppose if this is the question. Okay, suppose if this is the question. Okay, so how can you calculate this probability? I will tell you a simple logic. First, let me sketch the PDF here. Not required, but okay, just let me sketch it for a moment. What is the PDF value here? Okay, the PDF, the random variable is between -1 to 7. So the PDF is constant. Okay, a flat rectangular curve having the value of 1 by 8 between -1 to 7. Okay, what is the probability that x is between 2 to 5? Okay, x is between 2 to 5. Okay, this is 2, this is 5. Now we know that. What is the probability that the random variable lies between a to b? It is given by integral a to b fx dx. Correct, na? Or it is equal to, integral also means area, na? So you can also say it is area under fx. Which area? For the given range when x is between 2 to 5. So how much will be the area here? Okay, the area is given by height into base. The height is 1 by 8 and how much is the base? Base is 3. 2 to 5, how much is the base? 3. So what is the answer? 3 by 8. What is the answer? 3 by 8. Correct? Yes, Bhanu, correct answer. Now, if you see 3 by 8 means one thing. Okay, 3 by 8 means one thing. What is that 3 by 8? The 8 is coming because the PDF has 1 by 8 and the 1 by 8 is coming because of 1 upon length. So, the denominator 8 means the total length. And why is the numerator 3? Numerator 3 is because of 5 minus 2. That is the length of the given question, the favorable length. The favorable length. So in uniform random variable, probability is directly written as favorable length 3 divided by total length of the variable. Total length is 8. So no need to write down the PDF or draw the PDF. Write down directly favorable length by total length. Okay, if it is uniform random variable. For uniform distribution, the probability can directly be written as favorable length is divided by total length. Okay. Can directly be written as favorable length is divided by total length. Okay, so these are some quick points that you should note about uniform random variables, correct? Okay, now let's see what type of questions can be there. Let x be a continuous random variable defined on the interval 0, 1 such that its probability density function fx equal to 1 for x is between 0 to 1 and 0 otherwise. Let y equal to log of x plus 1, log to the base e. What is the expected value of y? See, what is clearly mentioned is fx equal to constant. Okay, what is that constant? 1 upon length. Okay, whenever PDF is constant, it's a uniform PDF. Although even if you don't know it is uniform PDF, doesn't matter. It's a question which is talking about expectation formula. Okay, what is the expectation of y? Expectation of y means, what is y? Y is a function of x. Okay, what is y? You can just again recall, whenever y is a function of x, okay, log of x plus 1 or any function, whenever you are talking about expectation of gx, what is the formula we already discussed in the beginning? Integral, okay, whatever expectation required, put it inside the integral or summation. Here, integral gx into PDF. Correct, na? So, it's an integral question more or less. It's an integral question. Now, the random variable is defined only from 0 to 1. The integral limit will change 0 to 1. What is gx? gx means log to the base e, that is ln x plus 1, this is gx into pdf value is 1. Okay, so it's a question which you have to, solve by just the integral of formula. Integral of which formula? Log of x plus 1. 0 to 1. Okay, now integral of log x plus 1. Log x integral is x log x minus x. So I will write down the answer here as x plus 1 log of x plus 1 minus of x plus 1. Limit from 0 to 1. So if you talk about upper limit, 1 plus 1, that is 2, and 1 plus 1 here also 2. 2 log 2 minus 2. This is the upper limit. Lower limit, if you put 0, you will get 1 into log 1. Log 1 will be 0, further minus 1. Log 1 is 0. Okay. So net answer will be 2 into log 2 minus 2 and plus 1. So minus 1. 2 log 2, 1.38. 0.38 approximately. Just recheck because log 2 is 0.69 approx. So 0.38 approximately, that should be the final answer. It's a question on expectation. Even if you don't know that whether it is uniform or not, doesn't matter. They have given the PDF enough. They have given the PDF, it is enough. Okay, next question. The unit interval is divided at a point chosen uniformly, okay, distributed over 0, 1 in R into two disjoint subintervals. It's a good question. Gate 25 CS 2 marks. Okay, the expected length of the subinterval, that contains 0.4. Okay, see, a unit interval 0, 1 is divided at a point chosen uniformly at random. Okay, suppose that point is simply x. That x can be anywhere between 0 to 1. Okay, that x can be anywhere between 0 to 1. Okay, is divided into two disjoint intervals. See, understand this way. Okay, this is 0, this is 1. Anywhere between them, x will come. But where about point f? 0.4. There are two possibilities there. Number one possibility that this is 0, this is 1, this is 0.4. Where is x? X may be here, x may be here. Okay, in the first case, let me assume that this is x. This is x. Okay, in the first case, let me assume that the x is greater than 0.4. Okay, the x is chosen as greater than 0.4. Okay. Now, so this is the length of the subinterval, expected length of the subinterval that contains 0.4. Okay, so what about the length? L. Okay, this L will be equal to this x, correct? This is the interval that contains 0.4. Now the L will be equal to x, right? The length will be equal to x only. Okay, second case, okay, 0 to 1, okay, this is 0.4 and maybe x is here. That means second case when x is less than the 0.4. Okay, what is the length of the interval? Okay, what is the length of the interval that contains 0.4? What is the length of the interval that contains 0.4? This is the interval that contains 0.4. So what is the length of this interval? 1 minus x. Got it now? So it's a good question where there are two cases to split. So what is the length? L. There are two cases. What are the two cases? The length is equal to directly x. When x is, first case, when x is greater than 0.4. When x is greater than 0.4. And on the second case, when x is less than the 0.4, okay, the length is 1 minus x actually. The length is 1 minus x, right? So number one thing what you can say is the length is like a function of x. The length is like a function of x. It depends on x. Okay, so question is what is the expected length of this subinterval? Okay, what is the expected value of L? Okay, where L is the function of x. So again the formula integral minus infinite to infinite g of x into fx dx. But what about fx here? What about fx? Okay, fx, the PDF of x. Okay, it is x is a point which is chosen uniformly distributed. So what about PDF? PDF 1 upon length. Okay, what is the length of this interval? 1. So 1 upon 1 will be 1. The PDF will be 1 for any value of x between 0 to 1. the PDF will be 1 for any value of x between 0 to 1. Simple. Okay. What is this 1? I'll write down here. What is this 1? This is simply 1 upon b minus a, that formula, 1 upon length formula. Okay. So the PDF is 1, but I have to split. This gx actually has two parts. Okay, this gx has two parts. Okay, for x less than 0.4. Okay, I'll write like this. What is the fx? Fx is 1 for x between 0 to 1. Okay, that means only integral of gx is required. Now, what is the integral of gx? Okay, integral of, okay, x is between 0 to 0.4. X less than 0.4 means 0 to 0.4, and there the gx is 1 minus x. This is the integral. See, this is the integral. Then, when x is greater than 0.4, that is integral from 0.4 up to 1, upper limit 1, then the gx has to be taken as x. Okay, so this is going to be, now 1 integral is x and x integral is x square by 2. In this case, 0 to 0 0.4 plus x integral x square by 2, 0 0.4 up to 1. This is how much? Lower limit is 0 only, 0.4 minus 0.4 square by 2, and the next one is upper limit 1 and lower limit 0.4 square 0 0.16 and then whole divide by 2. Okay, so this is how much? 0.4 minus 0.16 by 2, 0 0.08 plus 1 minus 0.16, 0.84 by 2, 0.42. So net answer is how much? This becomes 0.32 and 42 and 32, 74. Check the calculation once. 0.74 is what is the answer I am getting. Good question. You have to understand what can be the length of the subinterval. Gate 25 CS 2 marks question. Okay, next question. A one-way single lane road, gate 25 civil 2 marks question. A one-way single lane road has traffic that consists of 30% trucks and 70% cars. The speed of the trucks is uniform random variable on the interval 30 to 60. The speed of the cars is uniform random variable. Okay, both the speed of the cars and trucks are uniform random variable. Okay, on the different intervals given. The speed limit is 50. The speed limit on the road is 50 km per hour. What is the percentage of vehicle that exceeds the speed limit? That exceeds the speed limit. Now see here. Okay, a percentage of vehicles that exceed the speed limit, and there are two types of vehicles. See here. This is a logical probability question. Only a simple point you have to use about uniform random variable. They have also given x is the uniform random variable on the interval alpha beta if its PDF is given by 1 upon length, 1 upon b minus a, same formula. So this we already know. This we already know. Even if not given, no problem. Okay, see here, vehicle means it could be what type of vehicle? 30% trucks and 70% cars. So vehicle could be a truck, okay, or could be a car. Okay, there are 30% trucks. Okay, the probability of getting a truck is 0.3, probability of getting a car is 0.7. Now, the speed of the truck can be anywhere between 30 to 60, but if it is more than 50, okay, it is exceeding the speed limit. Okay, so truck also, if there is a truck also, it may exceed the speed limit. It may exceed the speed limit or not exceed. Okay, now the only question is, now the only point is, okay, what is the probability that a truck will exceed the speed limit? If I write down individually, what is the probability that a truck will exceed the speed limit? Okay, speed limit is 50. The truck exceeding speed limit means the speed of the truck is between 50 to 60. Okay, the speed of the truck is between 50 to 60. Okay, that means the probability that the speed of the truck is between 50 to 60. Upper limit is anyway 60 for the truck. Okay, now for uniform distribution, I told you the probability can be calculated directly by length. What is the favorable length? 50 to 60, 10. Total length, 30 to 60. Total length is 30. So this is 1 by 3. Okay, similarly, what is the probability that any car will exceed speed limit? Okay, it means the probability that the speed of the car is more than 50. Okay. More than 50, but the range of the car is 40 to 80. So that means upper limit is 80. So what is the favorable length now? 50 to 80, 30. And what is the total length? 40 to 80 is 40. So this is 3 by 4. So that means what is the probability that truck will exceed the speed limit? Is 1 by 3. It will not exceed means 2 by 3. Similarly, any car also may exceed the speed limit or may not exceed the speed limit. The car exceeding speed limit has the probability 3 by 4. Not exceeding 1 by 4. Okay, question is, what is the probability, later we'll convert to percentage, of any vehicle, okay, what is the probability that any vehicle, okay, will exceed the speed limit? So you have to break into two cases, na? Just like total probability. Okay, probability vehicle. Now, number one vehicle may be truck with probability 0.3 and it exceeds the speed limit with probability 1 by 3, or because these are the two cases that you require. Favorable case, here you exceed the limit, here you exceed the limit. Okay, so we need the probability of these two cases. The first case probability 0.3 and 1 by 3. Second case probability will be probability of a car 0.7 multiplied by it exceeding the speed limit 3 by 4. Okay, so this much is how much? 0.3 by 3, 0.1, and 0.7, 2.1 divide by 4, 0.5, okay, 25. Okay, so net answer 0.625, or in percentage 62.5 percentage. 62.5 percentage. Okay, 62.5, round off to one decimal place only, 62.5 percentage. Okay. Next question. Consider that x and y are independent continuous valued random variables with the uniform PDF given by x is uniform in 2 to 3, y is uniform in the interval 1, 4. What is the probability y less than equal to x? Okay. Now, gate 21 instrumentation 2 marks question. Normally, many places you will find the solution of this question by joint PDF. I'll give you a simple logical method actually. X and y are independent continuous values random variable with the PDF. Okay, with uniform PDF, x is uniform in this interval, y is uniform in this interval. What is the probability y less than equal to x? Let's draw a simple curve. Okay. X can take any value uniformly at random between 2 to 3. Y can take any value between 1 to 4. This is the range of y. Okay, so if I ask you the sample space, you can draw the sample space in a 2D diagram because two variables are involved here. Okay, and what is that sample space? Okay, it will be like a rectangular box. X is between 2 to 3, y is between 4 to 4, 1 to 4, and this is like the sample space. Okay, any value of x and y will be within this rectangle because x is between 1 to 3 and y is between 1 to 4. All values are satisfied. Sorry, x was supposed to be between 2 to 3. Sorry, x was supposed to be between 2 to 3, not 1 to 3. Okay, this one. Right. What is the probability y less than equal to x? Okay, think about the line y equal to x. Okay, can we think about the line y equal to x? Yes, why not? Y equal to x is simply a straight line which is passing through origin. This is the line y equal to x, line of slope 1 passing through origin. Now, if on this line y, oh, I'm so sorry. Okay, basically on this line y equal to x, what is the probability y less than equal to x? So, where will be y less than x? Anywhere below the line. Okay, but we have to be always inside the sample space. That means this is what I want. Y less than equal to x inside the sample space. Sample space is like universe. You cannot go outside it. Okay, the value of x are only here to here, the value of y only here to here. Okay, so now tell me, what is the probability, rather than, drawing the joint PDF, I have a simple idea here. what is the probability y less than equal to x? Okay. Now, because it was a 2D picture, it has created a region. Okay, the sample space, I will mention here separately once again that this is what is my sample space, the orange box, you can say the orange rectangular box, and then this green shaded portion is something known as the favorable region. Okay, this is your favorable region, and sample space means total region. So because it's a 2D region, and for any 2D space, what is the normal property you take is area. To talk about the surface area, probability y less than equal to x can be calculated simply as favorable area to be divided by total area. Favorable area divided by total area. Now, what is the favorable area? Okay, the favorable area is area of a trapezium. Okay, this is the trapezium that is formed with two parallel sides. So, half into sum of parallel sides. How much is this? 1 to 2 means 1 unit. This is 1 to 3 means 1 unit, 2 units. Okay, half into sum of parallel sides, distance between parallel sides. What is distance between parallel sides is 1. Divided by total area. What is the total area? Total area is the, sorry, for total area I don't need half. Total area means rectangular area. Rectangular area is base multiplied by height. Okay, that is 3. Base is 1, height is 3. Okay, so the net answer will be simply 1 by 2. That is 0.5. That will be 0.5. Okay, 0.5. Okay. Gate 21 instrumentation 2 marks question. Okay. Let me know if there is any doubt in this approach. Now, put this as homework. Gate 24 EC 1 mark question on a similar line. Okay, x and y are independent and identically distributed random variables distributed uniformly in the interval 0, 1. What is the probability x greater than equal to y? Probability x greater than equal to y. This is even more simple because both of them are between 0 to 1, 0 to 1. That's it. Okay, 0 to 1, 0 to 1. You solve it, I'll let you know the answer also. Here you will get the answer again as half. It's not always necessary, but again here you will get the answer as half. Okay. Okay, so that one was a similar question. Okay, only data is different rather, I would say. Okay, for such cases also no need to go for any joint PDF or something of that form. You can solve it directly also. Okay, what is there in the next question? Okay, gate 25 doubly 2 mark question. Okay, probability y minus, yeah, that's what. Now see, that is another way, but again you will have to go for convolution. Y minus x, whenever random variables are added or subtracted, you will have to talk about convolution because they are independent. Correct. One approach is, I'll give you the hint. Okay, not actually required. See, what you're telling is y minus x less than equal to 0 or greater than equal to 0. Y minus x, you think about y plus minus x. So you first have to write down the distribution of minus x. Okay, and then convolute with the distribution of y, because whenever independent random variables are added, the net PDF is the convolution of independent PDF. Correct? And then suppose this is some random variable z. This is some random variable z, which is y minus x. What is the probability z? Then you have an individual PDF, z greater than 0, z less than 0, but it will be time taking. Na? So it's a simple approach here. Okay, you can try this directly. For uniform PDF, you can try this easily, right? If it was non-uniform, see, then the thing might be different. Okay, but yeah, what you're suggesting is this particular approach, Bhanu. Okay, correct for this question, but little bit more time taking. Got it, na? Next question. Yeah, where we were? Yeah, gate 25 2 mark question. X and y are two random variable related by y equal to x square. Y equal to x square. Okay, let Px and Py be their respective, PDFs. Okay, with the PDFs, Pxx and Pyy. Okay, and the PDF of x is given. Pxx is 1, x is between 0 to 1. That means it is a uniform PDF, constant, 1 upon length. Okay, choose the correct option. What is the PDF of y? Choose the correct option. What is the PDF of y? Now see, there is a general formula also, but rather than formula, I want you to focus on approaches here. Okay, rather than many formulas. See, what is y equal to x square? This question will use approach, okay, of CDF. Y is x square. Okay, let me start with the CDF of y. How do you write down the CDF of y? CDF of y, suppose FYY, okay, the CDF formula is given by probability y less than equal to this value small y, okay. Now, what is the relation between y and x? The y is given by x square, so it is probability x square less than equal to y. Okay, so you come to the probability of x that can be calculated because x PDF is given. Okay, you can write down this x square less than y. That means what about x? Okay, what about x? X square less than y. That means x can be between minus root y up to root y. Minus root y to root y. But what about x PDF? Okay, what about the x PDF? This is the x PDF, PXX, which is 1 from 0 to 1. Rectangular, uniform PDF. Okay, this is the PDF of x, correct na? Okay, so when you say, or I'll redraw this PDF here, when you say x, because x is positive only, so you will write down this as x is between 0 to root y, or even if you don't write down, I'll directly calculate the answer from the PDF. Again drawing the PDF of x here. PDF of x I'm again drawing here, PXX, this one. Okay, so what you want, x is between minus root y to plus root y. Okay, suppose this is some value root y, this will be minus root y, so that is automatically not required. This much is required because x cannot be below 0. Okay, so how much is the area? Probability is also corresponding to area for the given region, and area will be height into base. Okay, right. This probability can be calculated as area, so answer is root y. Now, this is the PDF of y. Sorry, this is the CDF of y. The question is calculate the PDF of y, and PDF of y, which is named as PYY, PDF is nothing but the derivative of CDF. Okay, derivative of CDF of y, and root y derivative 1 by 2 root y. That is the answer. Root y derivative is 1 by 2 root y. Okay, what about the range of y? Okay, now what about the range of y? Y is x square, x is between 0 to 1. Okay, y also will be between 0 to 1. Minimum 0 square, maximum 1 square. Okay, so y is also between 0 to 1. Okay, so the PDF of y is 1 by root y, 1 by 2 root y for y between 0 to 1. 1 by 2 root y for y between 0 to 1. That is A is the correct answer. 1 by 2 root 5 for y belonging to 0, 1. Right. Next question, gate 23 EC 2 marks question. A random variable x which is distributed normally, okay, normally distributed as n 0, 1. That is the standard normal random variable. This is known as the mean. This is known as the sigma square. Okay, what is the formula for the normal distribution? Okay, a quick review. The normal distribution formula, the normal PDF formula is given by 1 upon sigma root 2 pi e power minus of x minus mu whole square by 2 sigma square for all values of x, which is a bell-shaped curve symmetric about the mean mu. Okay, symmetric about the mean mu. Okay, mu is the mean, sigma square is the variance. Okay, and this is clearly a symmetric curve. Okay, now a normal random variable is said to be a standard normal random variable if it has 0 mean and unit variance. So normally we represent any normal random variable by the notation n mu comma sigma square, having the mean mu and variance sigma square. So standard normal random variable is distributed by the notation n 0, 1, 0 mean and unit variance. Okay, suppose I call the normal random variable as z or x, any name you can give. So putting the value of mu and sigma, you simply get 1 by root pi e power minus z square by 2. Okay, for the previous question only this much information is sufficient. Okay, let's come to the question. What is the question now? Okay, it's a good question for EC. A random variable x which is uniformly normally distributed undergoes the transformation y equal to hx. So y equal to hx, given the transformation is given in a graph. Okay, y depends on x as per this graph. The form of the PDF of y, okay, in the options given below, a, b, c are non-zero constant and gy is a piecewise constant. So it's a pure conceptual and understanding question. See here, what is y? Okay, what is y? See here, if you look into the graph, when x is less than minus 2, see 1 by 1, case by case, if you understand this graph, for any value of x less than equal to minus 2, what is the value of y? What is the value of y? the y is constant minus 1. Okay, then second case, okay, when x is between minus 2 to minus 1, minus 2 less than x less than minus 1. Okay, then y depends on x. How? It's an equation of line. What is the equation of this line? Okay, mx plus c. Okay, mx plus c. What is the slope here? Slope will be height is 1, base is also, sorry, height here 1, base also 1. Yeah, the slope is 1, it's an increasing line. So what is the equation of this line? X. And it is going to have the y-intercept also 1 only. Okay, x plus 1. Okay, x plus 1 is the equation of line. This line will also have the same equation, x plus 1. Okay, now coming here. So y depends on x as x plus 1. Okay, third case, now when x is between minus 1 to 1, when x is between minus 1 to 1, y is fixed at 0. Okay, so many times y has single value only. Okay, then when x is between 1 to 2, y is again x plus 1. Y is again x plus 1. And fifth case, when x is greater than equal to 2, y is again taking the constant value 1. Y is again taking the constant value 1. Okay, that means for specific portions, y has 3 constant values. Okay, y has 3 constant values. Okay, I'll summarize the whole thing into 2 parts. Okay, what is the whole thing into 2 parts? Y is taking the value minus 1 or 0 or 1. Okay, right, y is minus 1, 0 or 1, or otherwise y is equal to x plus 1. I'll start here. Y equal to x plus 1. For what condition? When x is between, or I'll combine the condition like this. When minus 2 less than x less than minus 1, or 1 less than x less than 2. Or simply let's put it like this. Now, when the modulus of x is between 1 to 2. When the modulus of x between 1 to 2. 1 to 2, this is also 1 to 2 in terms of magnitude. Otherwise, y takes the value minus 1, 0 or 1. Otherwise means again there are different portions. I'm just combining it in a single portion. Okay, in a single portion. Okay, now y taking the value minus 1, 0 or 1, specific set of values is a discrete random variable. Okay, but y depending on x plus 1, where x is a continuous random variable. X is what? X is a normal random variable, means continuous. Okay, means continuous. That means under this special case, y is a mix of discrete and continuous random variable. Okay, is a mix of discrete and continuous random variable. Right, now if it takes a discrete value minus 1, 0 or 1, I'll again write down y takes the value minus 1, 0, 1 or x plus 1. Okay, this much portion is discrete, and discrete random variable will have discrete PMF. Okay, so if you want to talk about the probability distribution, okay, probability distribution, okay, because it has only 3 discrete points, the probability corresponding to these points, some probability will be there, not required. Okay, but suppose if I tell you what is the probability y equal to 1, suppose a, I can write it as a delta y plus 1. Single points are always represented by impulses, na? Okay, plus b delta y plus c delta y minus 1, meaning that whenever, see, now impulse means single point activity. Now whenever y equal to 1, these two impulses will be activated, and whenever y equal to 1, the probability distribution will be c. Some value c not required, but not only this, it has some continuous part for which PDF can be calculated, probability distribution can be calculated, because that continuous part is related as x plus 1, x is normally distributed, but are they asking? No. Okay, they are simply asking, look into this, correct answer will be having delta y plus 1, delta y minus 1 and some function of y. Gy is a piecewise continuous function of y. Piecewise, piecewise means only in pieces, because this function will only exist, okay, when x is between these two ranges. When x is between these two ranges, okay, only in particular piece. Okay, plus g of y corresponding to, okay, corresponding to this. Okay, corresponding to this, corresponding to this, corresponding to this, and this will correspond to this. This is what is the logic of this question. What is ABC? What is the exact probability? Also not required. Correct answer has to be option number B. Okay, tell me any doubt here. Okay, now this question, although does not require any particular details, further details of normal distribution, even the formula also is not specifically required here. Okay, but just I told you a formula as a quick revision. In the PDF, I will leave this slide so that you can revise if you want the normal and standard normal distribution, the symmetry point. As I already told you, it is symmetric, and that is a very important point. Okay, symmetric about means that the probability or area will be divided equally about the mean. All these points, okay, right? And then the 1 sigma, 2 sigma, 3 sigma rule, on the which there was no PYQ in the past 5 years. That is why you have not used this in the question. But in the PDF, I will still leave this slide so that this PDF serves as a revision for you. Okay, it will serve as a revision for you. Again, guys, next important update for you is the Ohm Institute has announced the online live courses for GATE 27 and GATE 28. I already told you, let me go back to that. Okay, the online courses have been announced for GATE 27 and 28, and the first online live course starts 2nd February. Yes, guys. So, you can, study on a live manner, in an interactive manner. Okay, sitting anywhere, any part of the country, you can attend this particular live course. Okay, and for this particular live course, there's a scholarship test that is announced. Yes, guys. Okay. On 25th of January, that is next Sunday, okay, from 6 p.m. to 6:50 p.m., that is exactly for 50 minutes, online scholarship test is going to be conducted. Okay, so that based on your performance, you can get huge benefits or discounts. Okay, your merit performance, will be reflected through this examination. The syllabus, basic foundation subjects have been kept, like for EEE aptitude maths, electric circuits, DC machines and transformers, and for EC aptitude maths, networks, EDC and digital circuits have been kept as the part of syllabus. Okay, if you get the rank anywhere between 1 to 3, you get 100% scholarship. Rank 4 to 10, 60% scholarship. And again, based on your performance, the scholarships are mentioned. You just have to register. The registration is free. The scholarship test is also free. You can immediately register by scanning this particular QR code. Okay, as I already told you, 50 minutes exam, 20 questions, 10 of 1 mark, 10 of 2 mark. It's online examination. You can appear it on app or web, anywhere. The details are mentioned here, right? Okay. So yes, guys, and already I told you in middle also that the first offline course at our Hyderabad center for GATE 27 also announced. Okay, it will be really great if you can walk down to the Hyderabad, if that feasibility is there, if you're passed out, or if you can manage coming to Hyderabad for offline, because in front of a faculty, and that too in a competitive atmosphere where hundreds of students are studying together with you, that really creates a big difference. Okay, so you can also, if possible, come to Hyderabad for our offline course. The first offline course for GATE 27 has been announced, and the date is 26th of February. That is after the commencement of the GATE examination. Okay, it is available for both EC and EE. Again, for any queries, you can contact our support number 95156940053 or go to our website ohminstitute.com. All right, and then if you are planning to prepare for the AE examinations, that is the Telangana or AP Genco Transco Discoms, the offline batch again at our Hyderabad center starts 21st January for Telangana as well as the AP. All right, guys. Okay, that's it. So as always, I'll share the PDF in my Telegram group, and as always, the PDF will be password protected. Okay, those who watch the video, those who are learning through this video, the PDF is only helpful for them, not any randomly. So I'll make the password for the PDF as the last question was on normal distribution. Let the password be normal, everything in small, NORMAL. Let the password be NORMAL, everything in small. Okay, that's going to be the password for the PDF. PDF will be shared to you by tomorrow in my Telegram group. If you're not connected, you can connect using this link. Okay. All right, guys. Bye bye. Thank you. Stay safe. Take care. Hope you enjoyed. Hope you got some insights about random variable questions coming up in the examination around discrete random variables as well as continuous random variables. Okay. Bye bye. Thank you. Stay safe and take care of yourself.